Good evening, everyone. Today we are continuing with our chapter Light, and this is the second part of the video. Today we will try to understand the ray diagrams related to the chapter Light. So we will see representation of the images formed by spherical mirrors using different ray diagrams. So first we will see the different rules. So there are different rules that we need to understand so that we will be able to make proper diagrams related to we will be able to make proper ray diagrams related to different mirrors. So we have basically two mirrors, concave and convex mirror. So we will try to understand the different ray diagrams. First we will see that what is the first ruling. First ruling, this is a concave mirror. First ruling is related to a ray parallel to the principal axis. This is our principal axis. This is a ray that is parallel to the principal axis. It comes and hits the concave mirror at one point and it gets reflected and it passes through the focus. Okay. After reflection, it passes through the principal focus in a concave mirror or appear to diverge from principal focus in a convex mirror. In convex mirror, what happens? It strikes the convex mirror, it diverges. When we retrace it back, the image is formed at the ray, not the image necessarily, the ray of light. If we retrace it back, it passes through the focus. Okay. So this is what is happening, that the ray of light that is parallel to the principal axis is hitting the concave mirror and it's passing through the focus. Same with the convex mirror, it is getting deflected. It is getting deflected, and then when we retrace it backwards, it is passing through the focus. Second thing we have to understand, a ray that is going through principal focus of a concave mirror or directed towards the principal focus of a convex mirror, after reflection it emerges parallel to the principal axis. Okay, very straightforward. The ray of diagram passed through the focus, hit the concave mirror, then it has gone parallel to the principal axis. Same thing happens in case of convex mirror. It hits the convex mirror, it gets deflected, and then when we take it back, it passes through the focus. Okay, or else we can say that a ray, if it is passing through the focus of convex mirror, it is, after reflection, it emerges parallel to the principal axis. See, this is it, how it is coming. It is going towards the focus. After reflection, it is going parallel to the principal focus. So these two things we understood, that if a ray is parallel to the principal axis, upon striking the concave or convex mirror, it passes through the focus. And if a ray is passing through the principal focus of a concave mirror or is directed towards the principal focus of convex mirror, after reflection it is emerging parallel to the principal axis. Okay. Okay. Next we see a ray through the center of curvature of a concave mirror or directed in the direction of center of curvature of a convex mirror. What is happening? Then it is reflected back along the same path because the incident rays fall on the mirror along the normal to the reflecting surface. It is passing through the center of curvature, hitting the mirror and going back at the same line. Same thing is happening in the convex mirror. Now, last rule is a ray incident obliquely to the principal axis towards pole on the concave mirror or a convex mirror is reflected obliquely. Means the angles I and the angle R, they will both be equal. And the same obliquation will happen, that the ray of light is oblique to some angle to principal axis towards the pole or concave mirror or convex mirror. It is reflected obliquely similar. Okay. In all these three cases, the laws of reflection are followed. Angle of reflection equals angle of incidence. Now let's move forward. See, there are 6 ray diagrams for concave mirror. I want students to practice all 6 of it and they have to memorize the table. There is there will be a table of ray diagram wherein we specify that where is the object placed, where is the image formed, all these things. So you have to memorize. So these are the ray diagrams. Okay, so at infinity, if an object is placed at infinity, what happens? The image will be formed where we'll understand. The ray of lights are coming from infinity. They are striking the concave mirror. After striking the concave mirror, the ray of lights are getting reflected, or they are all converging into the focus of the mirror. Okay. So the image is formed at the focus. So image formation in a concave mirror will take place at the focus when the object is kept at infinity. Now the second thing we see is the object is kept beyond the center of curvature. Image will be formed where? That will understand what will be the nature of it. Here the image formed is a point sized and virtual. Here what will happen, image is where the image will be formed. We'll see. Object is kept beyond center of curvature. One ray diagram will hit the concave mirror, it will go through the focus. Other will pass from center of curvature and it will go back. Image formed is laterally inverted, erect and diminished size, and it is formed between the center of curvature and the focus. Third point, C, we see that the object is kept at the center of curvature. One ray diagram hits the mirror at D, it goes through the focus, other one goes through the focus and is parallel. So the image is formed at the same point at the center of curvature, and it is formed inverted, and it is of the same size. Okay. Same size as that of the object, same size image is formed. Next we see the object is kept between center of curvature and focus. Okay, so one ray hits the concave mirror, goes through focus, other one goes in an obliquely M and goes backwards. So image is formed behind center of curvature, inverted, and it is larger in size. Next, what will happen if the object is kept at the focus? One ray will go like this obliquely, it will go backward, another will hit the mirror and it will go passing through the focus at parallel. So both of them will be parallel. Somewhere at infinity they will meet. So object will form somewhere at infinity and it will be enlarged in size. Last thing we need to see is if the object is kept between focus and the pole. If the object is kept somewhere between focus and pole, one ray will hit here, it will go backwards, it will pass through center of curvature. Other ray will hit the pole and it will be deviated obliquely. Now this will go down here, this will go somewhere here. Both rays will meet somewhere behind. So an extremely enlarged image will be formed behind the mirror. So these are the 6 different cases of image formation by concave mirror. We will see this is a table. Now what students have to do, students have to memorize this table and the previous ray diagrams. Definitely it will be asked in exam. Either they will ask you to draw the diagrams, or they will ask you in some form of a MCQ question that if object is kept here and here, where the image will be formed, what is the nature of image. In all the cases, what the student needs to know, they should be thorough with all the 6 ray diagrams. They should have memorized this table completely. Position of object is at infinity, position of image is at focus. It is highly diminished point size, real and inverted. Most of the images formed in case of a concave mirror is real and inverted. If the object is kept beyond C, image is formed between F and C, diminished, real and inverted. At C, position of object at C, image is also at C, same size, real inverted. Between C and F, beyond C. Position of object is between C and F, position of image is beyond C. Size of image is enlarged, nature of image is real and inverted. If it is at F, the image, position of image is at infinity. It is highly enlarged and it is real and inverted, and it will be real and inverted. Now between P and F, okay, between P and F, then image, position of image will be behind the mirror, size of the image is enlarged, and the nature of the image is virtual and erect. Okay. So when the object is between F and P, focus and pole, image is not obtained on the screen. Here virtual image can be seen in the mirror. So just memorize all this. Now let us see what are the uses of concave mirror. This is important. This can be asked in exam, that list the various uses of concave mirror. Where are concave mirrors used? So first of all, concave mirror is converging the light. So where is it used? It is used in the torches. Whatever torch we use, It's a concave mirror. Okay, so it is used in torches, it is used in searchlights, it is used in vehicle headlights to get powerful parallel beams of light. It is used as shaving mirrors to see larger image of the face. It is used by dentists to see images of teeth of patients. Large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. Okay. Image formation by a convex mirror is the next topic. We'll try to understand how an image is formed in the convex mirror. This is a convex mirror. This is a convex mirror. Show a pencil in upright position in front of convex mirror. It is image in the mirror is erect and diminished. As the pencil is moved away from the mirror, the image becomes smaller and moves closer to the focus. Now, in case of a convex mirror, we only have two ray diagrams. We had 6 ray diagrams in concave mirror. For convex mirror we have only two, so we have two position of object to study the image formed by convex mirror are shown below. First is at infinity. The object has been kept at infinity, so where will the if the object is kept at infinity, where the image will be formed? Again, all the ray diagrams will come, hit the convex mirror, and it will get diverged. When we retrace the rays behind, image will be formed at the focus, and the image will obviously be highly diminished and point size and virtual and erect. Both the images formed are virtual and erect. Now the next point that we see is if the object is kept between infinity and pole, somewhere between. One ray of diagram will go and hit the convex mirror, it will get diverged. Other ray of diagram will go obliquely, it will come back. When we retrace the paths of light behind, somewhere in C they will form, and a very small image, virtual and erect diminished image will be formed. Okay, and the image is formed between P and F, behind the mirror, P and F. Okay, so that's it, that's the understanding. In plane mirrors and concave mirrors of any size, we cannot see a full-length image of a distant object, but it is possible in convex mirror with a wider field of view. Okay. In convex mirror, we can see wider field of view. So a convex mirror is fitted in a wall of Agra Fort, facing Taj Mahal, to observe the full image of Taj Mahal. Okay. Clear? Yes. Now we will see the uses of convex mirrors. Convex mirrors will give an erect, diminished and virtual, erect, diminished and virtual image. Also they have a wider field of view as they are curved outwards. So they have wider field of view as they are curved outwards. They give erect, diminished and virtual image. So they are used as rear view mirrors in the vehicle. Car, we all have car. In the car we have two flaps. So in that, convex mirrors are used for wider field of view, so that we use a convex mirror in the car headlights. Why? Because not headlights, sorry, in the car rear wing mirrors we are using a convex mirror. Why are we using? So that we get a wider field of view, we can see more vehicles coming from behind, and we have a wider range of view. So in cars rear view wing mirrors we are using a convex mirror. It is a very important point to be kept at mind. So we will end this video after discussing the sign convention. Sign convention is very important for solving numericals related to light chapter, be it convex concave mirrors or concave convex lens. So in this convention we have the pole of the mirror is taken as the origin. Principal axis of the mirror is taken as the x-axis of the coordinate system. This is the new Cartesian sign convention for spherical mirrors. Now if the object is on the left, see, anything distance towards the left is taken negative. So whenever the object is on the left, it is taken negative. And whenever there is a distance towards the right behind the mirror, it's positive. Okay. And anything height upwards is positive and height downwards is negative. This is similar to the Cartesian plane that we study in mathematics, something like this. We study that the vertical planes vertical plane is the y-axis, horizontal is the x-axis. So what do we study? That this is origin, this is x-axis, this is positive, this is negative x-axis. The top one is positive y-axis, below one is negative y-axis. Similar convention is used in solving problems related to light in the sign convention for the spherical mirrors. Like, what is the convention? Anything that is placed on the left side or distance towards the left side of pole is negative. So object is placed in front of the mirror, negative. U will is the object distance taken negative. Anything on the right hand side, distance was right, is taken positive. Anything on the bottom, height downwards negative and height upwards is taken as positive. We will learn more about it in the next video. Thank you all for joining us today.